Hello, Dajaha. I'm Alex from Mysten Labs, and this is going to be a highly technical session that I'm going to talk about programmable transaction. As most of you might know, Mysten Labs is trying to get Sui onto mainnet, and we are on a very rushed schedule. So, and for that we introduced a lot of breaking changes. This was I think it's the most critical one that affected the community the most, because we changed the way that you interact with the chain quite radically. So, today I will try to explain. So I will give a brief history on how transactions were on Sui and why did we end up like choosing programmable transactions. I will explain how a programmable transaction runs from high level with a simplified example, and then I will have some code examples which you can follow along. I intended to do a live coding, but we can do it in the office hours. So transaction, what do we need? So what does Sui require in order to be user friendly and in order to be usable? So any transaction should be possible. So a user must be able to do any transaction. Then you have to transfer objects. You know that in Sui everything is an object, so transfers are like 90% of all the transactions. That should be fairly easy to be done. And a lot of transactions are coin transactions and balance exchanges, and coins are also objects on Sui, so that's also something that needs to be done. And the last thing is that you need to repeat them and batch them. So in order to achieve your end result, you may want to do more transactions than one and you don't want to do them sequentially. You want to send them all together and let the VM do them. So the history of how we started, and that's not such a long history. In summer, we didn't have any endpoints. We only had move. Because with move, you can write any transaction on Sui, you can express it in move, whether it's a simple one or it's a very difficult one. But that has its downsides. Back then, we thought we were good, anyone can do anything he wants on Sui. But the downside is that even for a transfer, someone has to write move code in order to be able to transfer or use someone else's move code, which is even worse because you have to trust someone else then. And then we thought, okay, so everything is objects. Let's make an endpoint. We made the first endpoint that it's called transfer object. Now everyone can transfer objects, and we're good. But that didn't last long, because when you're transferring objects, you need to pay gas, and everyone who used Sui and was back in the days knows that with transfer object you needed another coin object, a Sui coin, in order to pay for gas. So you couldn't send like your coins. You couldn't send all of your coins. An account that had Sui could never empty, because you needed a coin that would pay for gas, and you always have some remainder. So we said, okay, then we are going to make a transfer Sui endpoint, which you can put your coin. The gas is going to be paid from that, and that coin will go to the recipient, and you have an empty account, and then we're covered. But then more edge cases came, and then we came the pay family of the endpoints. That's pay Sui, pay all Sui, pay, where you can have multiple recipients and multiple amounts. You can put many coins, and the gas are paid from those coins. You could empty a transaction, and that went very well. But the problem is, you see, if this timeline continued, everything would get larger and larger and larger. So there were a lot of issues. The edge cases, every time we looked at it and we did a revision, we realized we could add something more and something more. Everyone who's doing programming realized that this is not something sustainable, because the responses were different. The limits, every function has its own, a native function had its own limit. There were atomic operation. Batching is still not possible today, because the batch endpoint that we have you can't have the same object in two different transactions, and that's not efficient at all. The entry functions in move couldn't return. So we decided to do programmable transaction, and let's see how that works. So a programmable transaction, first, let me reiterate the fact that move is the most expressive way. So if you want to do something complicated, the best way is to do it with move. But with programmable transactions, you have a simple set of commands. That's a move call, so you can call a move function. You can do a publish and update package. That we can do split, merge coins, and transfer coins. So you can issue those commands. Each command is a small transaction. You can issue many of them, and create a bigger transaction, which we actually call transaction block, that is perceived as one transaction by the chain. This makes things more efficient and more cost-effective. You need to have the inputs first, so the inputs can be an object reference, and I'll explain what is that. An object, which gets turned into an object reference in the end, or a pure type, which is things that MoveVM can understand, is a U64, a vector, or an address. So the commands are on the inputs. You say I have input object and pure, and you do a move call with the object from the input, and then the result from the move call, I want to transfer it to that address, which is a pure. And I will explain how that goes. The core components of a programmable transaction are the gas coins, which you can set. You can set an entire array of gas coins. You need to have your inputs, and then the commands, and some metadata. You need to know who's the sender, who's the one who's going to sign. You can set the gas price if you want to pay more gas. The gas budget is always a need. Everyone knows that on Sui. And the gas owners, because we have a sponsored transaction and someone else may pay your gas. So we allow for that as well with programmable transactions. How this goes. So let's say that I want to make a programmable transaction that is that calls the buy-NFT function twice, once with 3 Sui and once with 4 Sui. What do I have to do? First, I have to set my gas. And I need the coin object references. It can be an array. This array is going to be merged into a single coin, and that coin is going to be the first coin, always. Then I have to create my inputs, and I tell them I want a pure value, which is a U64 in this case, that's with the value 3, and I want another pure with the value 4. And what is going to happen with those inputs? I want the commands now. I want to split those coins. I want to split coins. I want to split the gas coin. You can actually use a coin as an input, an object, but the best practices are always, if you have to do transactions with Sui, use the gas coin. It's the most effective way and the most sure and most secure way. So I want to split the gas coin into input 0, which is what's input 0 is the 3. I want to split the gas coin into 3 Sui and into 4 Sui, which is input 1. And then I want to take that result, I want to take the result and send it to the buy-NFT function once, send it to the buy-NFT function twice. So you have a result. The result is again an array of nested result. Nested result 0 is just the result of the split coins. So the split coins gave a split coin 0 that has the 3 Sui and the split coin 1 that has the 4 Sui. And you take, so result 0 should be nested result 0, and the 0 index over here is the first split coin. And this is how it works. Oh, I have a lot of time. So next, I want to do a practical example. Sorry, I need some. Can you refresh? I have some more slides. What? Yeah.
You'll have to airdrop it to it.
Oh, never mind. Let's just continue. So, yeah. I also had that issue, but it's my fault this time. Before we go to the example, I want to address one issue that we have right now with Sui. We have very little SDKs. We have SDK for TypeScript and Rust. The Rust needs more love as well. The TypeScript is the one that's really up to date. So what happens if you can't do a programmable transaction because you need an SDK? We have still preserved the endpoints, the old endpoints with the PaySui, the batch transaction, the publish, and all those. If you have checked the JSON RPC, you will see that right now they are tagged with unsafe. And they are going to remain until all major languages will have their SDK, and that's going to come as soon as possible. Well, when all major languages have their SDK and can build a programmable transaction, then you will then those endpoints will be removed. They are tagged with unsafe because you have to trust the full node that you're sending the transaction to. A programmable transaction, the only thing that it does in the end is the thing that it outputs are some bytes. It's an array of bytes which the move VM can read. So when you send it to a full node, they will respond with some bytes that you can't read. So if you put like send the coins to this address, the full node, if it's a malicious one, can change the address. It will return some bytes, and you have no way of figuring out if it's correct or not, unless you send it to more full nodes and cross-check the response. So if you are going to use the unsafe endpoints, make sure that you trust the full node or you run your own full node. And this is some TypeScript example that I want to do some live coding of this, and maybe we can do it in the office hour later. So I named the function getTXBytes. This is the object reference that I was talking about. In Sui, everything is an object. Every object has an object ID, but there are other two pieces of metadata that are very important in order to identify an object, which is the version. The version of Sui is used in order to make sure to prevent double spending and other such cases. So whenever a transaction happens, the version of any object will increase, so you can't do the same transaction twice because you will not have the same version. And a digest, this is just a Blake to be the hash digest with the object's data. So for a coin, will be its ID and its value, its balance. And this is actually how an object is represented on chain. If you want to build this transaction, this programmable transaction is offline, which means that you don't have to call any full node in order to build it, except for this part. So if you want to set the gas, which you will send it with coin references, you have to have gotten them before starting to build a programmable transaction. Though this can be gotten from any response, so if you send an object or create a new coin, then in the response you will get all this data. Otherwise, you have to query a full node with a getObject function. If you have the object references, though, then you can build an offline transaction, which is the request that I have very, very often from our partners. The first step is to set the gas payment. So we set an array of object references. I repeat, these coins are going to be merged all in one. A very important point over here is that the merge is happening every time. So even if the transaction fails, your coins are going to be merged. This is very important because usually a transaction on Sui, when it fails, nothing changes, but this thing is going to change. So any coins, if you have an array of coins during a programmable transaction, even if it fails, it gets merged. It's a cheap way to do merges as well if you want, but it's not indicated. A gas budget has to be set. This is on DevNet. This gas budget is not representative anymore, and it's not going to be representative of Sui. A good gas budget is around 3 million MIST right now. This is gas budget. Oh, let me explain gas budget. It's another thing that I get a lot. Gas budget is the maximum price I am willing to pay for this transaction. So when this transaction is going to go, the first check that it's going to do is the VM is going to calculate how much gas it needs. It is going to calculate gas for computation, we have it separate, and gas for storage. And the gas computation and storage has to be lower or equal than this value. If it's above, that transaction will fail. I'm still going to pay a bit of gas for the computation that it had to do. It will be a lot less, and that's all. And this is going to get merged as well. It's calculated in MIST, so it's MIST is not computation units. It used to be computation units, but it's not anymore. And remember, it's the upper tolerance that I have for any transaction. It's not something that affects the transaction or the transaction speed at all. Then I have to set the gas owner. That's because of sponsored transaction. In this case, it will be me, the same guy that is doing the transaction. And that's usually the case, unless you want to do an error or something like that. Then is the gas price. The gas price, this is a way that you can manipulate how much gas you want to pay. If you don't set that, then it's going to use the reference gas price. This is the gas price that all validators agree and must honor. Means that if I pay at that gas price, the validator must process my transaction. And in DevNet, it's set at 1. If I set it at 2 here, I would have paid double the gas, and in the near future, yet is not implemented, that means that my transaction would go faster. The validators will actually choose the higher paying transaction over the lower paying transaction. But that's not in the code yet. But that's the way to pay more gas if you want. I have to set the sender. This is the one who is going to sign the transaction, so it has to match. It's the one who has to own these coins, so I can't use another guy's coin, so it has to be mine. So this is an address, so they must belong to me. And then I'm calculating the things that I need to do in order to create the commands. The first command I want to do is I want to split the coins, because this is a pay Sui. Pay Sui works that I'm giving an array of coins, I'm giving an array of recipients, and an array of amounts. The coins are merged into one coin, then it's split again according to the amounts, and every amount goes to the recipients. The recipients and the amounts has to be the same length. And the first recipient gets the first amount, the second recipient gets the second amount. The recipient can be the same person, but they will get different amounts, so more coins. So first I have to create, I named it pure amounts. The naming is not quite well, I had to revisit it, but pure means that everything in the programmable transaction is serialized in BCS. That's binary canonical serialization that Sui uses. So you have to call the TX pure or TX object in order to create. That's another array of bytes, and it's just a serialization. So for each amount, I have a map of amounts. Again, another thing. Remember that we are using only strings right now, and it used to be numbers, but everything is a string. And here you set the amount. By default, if it's a number or number-like value, it's going to be U64. That's why I didn't have to set it. In cases that you want to say what kind of serialization you want to get, if this was going to be a U8, for example, I have to put a comma and a U8 to explain the type. By default is U64, so I'm just mapping and I'm creating a new array that has the BCS serialized amounts. And then I create the new coins, which is the nested result that I talked previously with the TX split. So this is the first command, TX split coins. I tell him to take the gas object, that it's all the coins merged into the first one, and split it according to the pure amounts. In this, here I don't have numbers, but it could be 3 and 4 in the previous case. And then I'm creating the transfer objects according to the recipient. So for each recipient, I'm taking the first recipient should get the first coin, the second recipient should get the second coin, and I'm making as many transfer objects as the recipient string, the recipient's arrays. And then I just call txbuild. Txbuild, as we will see in the next example, takes an argument, usually takes a provider, a full node address, in order to make your transaction. If you have done all this and you have the object reference is ready, then you don't need to call the full node, so you don't need to pass a provider. The next example is a shorter example. This is just how to make a move call, which is a bit different. In this case, though, I need a provider. This is a DevNet connection, so it's just a connection to the full node. I have a price and I have a wallet. That's just an object. I'm creating the transactions. I want to split coins. Here I'm not inputting the gas, because if I don't want to do it offline, then the SDK is going to calculate the gas for you. It's going to take the right coins, so you don't have to worry about that. That's only for the TypeScript SDK, though it's not true for the Rust SDK. I'm going to take the gas, and I'm going to make a coin of 10,000 because I want to send in the move call 10,000 Sui. The way that the move call is called is shown over here. I have to set the target. The target is an address on chain, the module name, and the function name. I want to call the function that is called mint inside the module that is called genesis of this address. And the arguments are the arguments that the mint function expects. In this case, it's an object at this address, another object at this address. This is how I'm creating object inputs that are objects on chain, and then a pure string. This is going to be a vector U8 and the payment coin. And I have also the type arguments over here. This min function means a copy, so it needs a type argument. This is from our Sui Friends project. So I have to introduce the type. And then I am transferring all the objects. So this min function will return, it's an entry function, will return an object. I have to do something with it. And I'm transferring immediately to the wallet address. And then I call the build with the provider inside, because this time I haven't set any object references. The provider is needed for every object that I'm inputting. It's going to get the references with the version and the object IDs. So this needs a call to the full node before it's built. After it's built, you just need to sign it and then call the execute. This is the presentation. I have some minutes for question if you want, and then an office hours for any dev that wants to ask some questions on this. Okay, good. Thank you very much.